dry air. Very good, Ahmad. So when you read the question, you can try to figure out what is the information you can extract from them. So 10 minutes will be ended. Okay. So calculate the partial pressure of the water vapor. So first of all, you want to know components of in dry air. This one is the air without any water, dry air. So you have this the component, oxygen, nitrogen, carbon dioxide, hydrogen. So you can see actually nitrogen is the major components, right? So carbon dioxide is actually not a lot yet, okay? But if it's too much, you will have problem. You have global warming, all right? So greenhouse effects. So you want to calculate the molecular, total molecular mass of air. So you have to calculate like this, volume, okay, times molecular mass. Okay, the atomic mass of oxygen is 16, oxygen is O2, so it's 32. Nitrogen is 14. Nitrogen always occur as N2, right? So it's 28. So, and then you times this volume ratio compared to dry air, times with the molecular mass of the individual component, you get molecular mass in the air for oxygen, for nitrogen, and so on. So this one is not significant at all. So you just put 0. Total molecular mass of air is here. All right. In exam, of course, I will not ask you to memorize all these things. If I ask this kind of questions, I will directly give you the total molecular mass of air equals to this 28.97. Okay. But you maybe should know how to get this molecular mass. So this is here times here. You get this molecular mass of the individual components in the air. And then you sum this up, you got this. All right. So the molecular weight of air is 29 and of water is 18. So do you know how to get 18?
H2O.
H2O, that's right. Yeah. 2 plus 16, right? Because 2 hydrogen. So the mole fractions of water, so there is a formula for this. So when you say mole fractions, you must have like divided by sum, right? So mole fraction of water, so means the mole of water divided by mole of water plus dry air, right? So mole equals to what? Do you still remember the formula?
Mass over molar mass.
Yes, very good. Yes, mass over molar mass by Isaiah 2. All right. So you already know it's 0.03 kg. All right. Actually, the SI unit for the molar mass is like the molecular weight is like kg, kg per mole. Okay, but in the lab usually we just use gram per mole. Okay. But here we're dealing all with kg and kg per mole. The SI unit is actually kg, all right? So divided by 1, because it's 1 kg of the, you want to calculate the mole of the dry air. 1 kg divided by 29 of the molecular weight of air plus this. Don't forget to plus. Usually in the exam, you are very rushing or panic, or maybe sometimes forgetful, so you forgot to plus this, the answer is wrong. And your answer is here is wrong, of course here is wrong as well. So be very careful. Even something simple is actually very easy to make trap you into big mistake. All right. So when you find out these mole fractions of water, this is Yi, right? So that's why the water vapor pressure Pi equals to P total times Yi. So it's Yi is this, okay? This is the P total, 100 kilopascal. So you got 4.8 kilopascal. Everybody clear?
Yes.
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 All right. So now we move to, okay, before that, I want to ask you one question about psychrometry. Okay. So can I know, anybody know why we sweat more in the humid area, like country or area, like in Malaysia, right? It's a humid, tropical humid country. So so the why we sweat more here when you are in, let's say, in New York. So I was in New York before during summer. So there are 4 seasons there. During summer, it's very hot. Sometimes it's hotter than Malaysia, but you don't sweat that much. Can anybody explain why we sweat more in Malaysia? Like, let's say last time there's no MCO thing. You went to the class to Kuliah of Science from Mahala. You walk under the, like, at maybe 1:30 p.m. very hot under the sun. You sweat a lot, right? Yeah, you feel very hot. But if last time when I was in New York, I walked to the class from my dorm. I don't sweat that much, although the temperature is the same. Let's say it's like maybe 32 degrees Celsius, but I don't sweat that much. Still dry, my shirt still dry. But in Malaysia, my shirt is wet, soggy, right? Because sweating a lot. So anybody can explain why?
I want to try.
Okay, sure, Ahmad.
Because the composition of the water in the air in Malaysia is higher than in New York.
Okay, good point. So why then, could you elaborate more? Why, when the compositions of air is water is higher in the air in Malaysia than New York, why we will sweat more?
I don't know.
Okay, good. You got the first part right. Okay. Any others want to try? I'll give you some hint then. I give you some hint. Actually, the question is tricky. Try to trick you from the phenomena you observe. So we feel like we sweat more in Malaysia. Actually, at the same temperature, we sweat the same amount of volume of water, the sweat, right? But you don't notice in New York. Actually, you doesn't sweat more. In reality, you doesn't sweat more in Malaysia. It's actually we are deceived by the observations of the shirt. Like, oh, my shirt is all wet by the sweat, but actually,
Because at New York vaporize.
yes. So why New York evaporize? The sweat evaporize?
Because the partial pressure of the water in the air is lower.
Yeah, because it's easier for the sweat from on your skin to evaporate it to the dry air compared to the moist air. The moist air is already saturated with a lot of water content, so it's harder for your sweat to evaporate it into the air. So back to the very beginning theory is we sweat when we feel hot, right? Usually we feel hot, then we sweat. Okay, so when you do some activity like farming under the sun, you sweat a lot, or running, the body generates a lot of heat. You sweat a lot because sweating is the natural mechanism of humans to cool down our body temperature. So how sweating can cool our body down? Because